Welcome back, students. Today we will discuss about the numericals on the reflection of light. In the previous lectures, we have discussed the image formation by convex mirror and concave mirror, and in this lecture, we are going to discuss the numericals on the convex mirror, numericals on the basis of convex mirror, concave mirror, and the reflection suffered by the rays of light, and we have to find the position, nature and size of the image formed by the convex mirror or either by concave mirror. Let's have some examples. Our first question is, find the focal length of the convex mirror having a radius of curvature 1 meter. So guys, as we know that the focal length f is equals to r by 2, and it is r by 2, half of the radius of curvature. If we draw a convex mirror, you know that a convex mirror is drawn in this form, and the radius of curvature lies in this side. Okay, here is the radius of curvature and this is the center of curvature, and it is the point pole. And we know that all the distances were measured from pole, and according to new Cartesian sign conventions, the distances measured towards the right side of the pole are positive and towards the left side of the pole were negative. So here the radius of curvature is a positive quantity for a convex mirror. If you are taking the case of a concave mirror, then in case of a concave mirror, the center of curvature lies towards the left side of the pole. So here is the radius of curvature for the concave mirror. We have drawn for both the cases for the convex mirror as well as in case of concave mirror. In case of concave mirror, the radius of curvature lies towards the left side of the pole, and in case of the convex mirror, the radius of curvature lies towards the right side of the pole. So the radius of curvature for the convex mirror is always positive, and the radius of curvature for the concave mirror is always negative. Okay, or if the radius of curvature is negative for the concave mirror, then the focal length also be negative, and the focal length for the convex mirror will be positive. Okay, so we are given that the focal length, we have to find the focal length of convex mirror of having radius of curvature is equals to 1 meter. Here we are given that r is equals to 1 meter. So we will take 1 as positive quantity. Okay, then the radius of curvature f is equals to r by 2, means 1 by 2, it will be equals to 0.5 meter. Okay, this is the answer for the question, that the focal length of the convex mirror having a radius of curvature of 1 meter will be equals to 0.5 meter. Okay, now take the next example. An object 4 cm in size. Here the data is given that an object is 4 cm is in size, means the 4 cm is the height of the object, and the height of the object is represented by h1 or simply by h. Okay, it is given that height of object is 4 cm, is placed at a distance of 25 cm from a concave mirror. So it is given that the distance of 25 cm means the object is placed 25, it is our concave mirror, and the object is placed 25 cm in front of a concave mirror. Suppose here is our object is placed, so we are given that the object distance from the mirror. So object distance from the mirror is 25 cm. Object distance, and the object distance is represented by u, and it is given that it is 25 cm. One more thing, students, object distance is always negative because the object is always placed towards the left side of the mirror. So object distance will always be negative. You don't have to confuse in this term whether the distance of the object is taken positive or negative. Distance of the object is always be negative. Okay, In place in front of a concave mirror of focal length 15 centimeter. Focal length of concave mirror. Focal length is 15 centimeter, and we have already discussed that the focal length of concave mirror is negative. So 15 centimeter will be negative. Okay, and we have to find the position, nature, and height of the image. So we have the mirror formula. Mirror formula, and it is 1 by f is equals to 1 by u plus 1 by v. Here we have to find the position of the image form. So we have 1 by v will be equals to 1 by f minus 1 by u. Now we will put the values of f and u. The value of f is 15 and the 15 centimeter is negative because we are taking the case of concave mirror. So 1 by f, in place of f I will write minus 15. Okay, and minus 1 by u, and u is 25 centimeter, and we know that object distance is always negative, so it will be minus 25 centimeter. Minus minus plus, we have 1 by v is equals to 1 by minus 1 by 15 plus 1 by 25. Okay, take the LCM, and the LCM will be 150. 1 by v will be equals to 150 will be the LCM. Here we have minus 10 and here we have plus 6, and it will be equals to minus 4 by 150, or v will be equals to minus 150 divided by 4. When we will cancel out it, this term, we have minus 3 7.5 centimeter, 37.5 centimeter. So it is the position of the image in front of the in front of the concave mirror. Here the negative sign represents that the image formed is also towards the left side of the pole, and if the image formed towards the left side of the pole, then it will be a real image. So from there we can conclude that the image formed is real. Okay, so here is the position and it is the nature of the image. The image formed is real because it have a negative sign. Okay, now we have to find the height of the image. Height of the image. For finding the height of the image, we have to use the formula for the magnification m. M is equals to h2 by h1 is equals to minus v by u. We have already discussed this formula. The linear magnification is equals to h2 by h1, and it will be equals to minus v by u. We have the values v, u, and h1. Let's put the values in place, and we have to find h2, and h2 will be equals to minus v by u multiplied by h1. Let's put the values. Minus in place of v, we can put minus 150 by 4, minus 150 divided by 4, and in place of u we can put 25, and 25 is negative, and in place of h1 will be 4 centimeter. h1 is 4 centimeter. Okay, minus minus cancels out each other, so we have minus 150 divided by 4 into 25 multiplied by 4 cancels each other, and it will be 6. So h2 will be 6 centimeter. h2 is 6 centimeter and h1 is 4 centimeter. We can observe that the height of the image is greater than the height of the object, so the image formed is enlarged. Okay, this is the numerical for the concave mirror when the object is placed at a distance of 50 and 25 cm in front of a concave mirror, and we have determined the position, nature, and the height of the image formed. Let's take some other examples. In the next question, we have given that an object of height 1.2 meter 1.2 meter is placed before a concave mirror. Means to say, we have a concave mirror here, and an object of height 1.2 meter is placed before a concave mirror of focal length 20 centimeter, and the focal length of the, suppose this is the point focus, and the focal length is given 20 centimeter. So the 20 centimeter is negative because the focal length of the concave mirror is always negative. Okay, focal length of 20 centimeter, so that the real image is formed at a distance of 60 centimeter. So here we have focal length 20 centimeter and image distance is at 60 centimeter. Here one thing is told in the question that the image formed is real at a distance of 60 centimeter. When the image formed is real, then the distance of image will be negative. Okay, distance of image formed is negative, so we have to find the position of the object. We have to find the position of the object u. Okay, let's take again the mirror formula. 1 by f is equals to 1 by u plus 1 by v. Here we have to find the value of 1 by u. So 1 by u will be equals to 1 by f minus 1 by v. 1 by f minus 1 by v. So 1 by u is equals to, in place of f we can put the value minus 20. So minus 1 by v, at place of 60 we can put minus 60, minus minus plus. So we have minus 1 by 20 plus 1 by 60. Take LCM. 60 will be LCM. It is 3 plus 1. It will be equals to minus 2 by 60. So we can cancel these terms and we have minus 1 by 30. So the value of 1 by u is minus 1 by 30, which implies u will be equals to minus 30 centimeter. So the object is placed at a distance of 30 centimeter when the real image is formed at a distance of 60 centimeter in front of a concave mirror. What will be and the next question in the same given that what will be the height of the image formed? We have to find h2. So we will use again the same formula as we have used in the previous question. M will be equals to h2 by h1 and it will be equals to minus v by u. Let's put the values one by one, and h2 will be equals to minus v by u multiplied by h1. So h2 will be equals to minus v. In place of v we will put 60 and it is minus 60 because the image formed is real, and u will be minus 30, and in place of h1 we will put 1.2 meter here. Here the height is given in meter, so we will use it in centimeter. When we will convert it into centimeter, it will be equals to 120 centimeter. Okay, here we have converted meter into centimeter because the object distance and image distances are in the centimeter. So we have to use the same system of units. So we have 120 here. Negative negative cancels out and the value will be 2 and h2 will be equals to 240 centimeter with negative sign. It means the image formed. H2 is negative means the image formed is inverted. So the image formed is inverted because the all the distances below the principal axis were negative. So the image formed is inverted here. Okay, let's take some more examples in the same manner. We have given a convex mirror is used for rear view mirror on a automobile. Okay, we have a convex mirror which is used as a rear view mirror, in an automobile, and it has a radius of curvature of 3 meter. Okay, radius of curvature r is equals to 3 meters. R is 3 meters, and the radius of curvature for the convex mirror is towards the right side of the pole. So r is positive. Okay, r is positive. Radius of curvature is 3 meter. Then the focal length will be equals to f is equals to r by 2, and it will be equals to 3 by 2 meter, or we can say 1.5 meters. Okay, if a bus is located at 5 meters from the mirror, a bus is located, suppose here is our bus which is 5 meter away from the mirror, the distance is given 5 meter. Okay, distance is 5 meter. So the object distance u is 5 meter here, and we know very well that the object distance is always negative. So u is negative here, u is minus 5 meter, and find the position, nature and the size of the image form. Again we have to find the same position, so we have to find v. Okay, so we will again use the mirror formula. 1 by f is equals to 1 by v plus 1 by u, and here we have to find the value 1 by v, and 1 by v will be equals to 1 by f minus 1 by u. Okay, let's put the values one by one. 1 by v will be equals to, in place of f we will put 3 by 2, but positive here because the radius of curvature and the focal length of convex mirror is always positive. So when you put the value of f here, 1 by f, in place of f you will put 3 by 2, and 3 is here and 2 is multiplied on the numerator. Then minus 1 by u, in place of u we will put minus 5, and minus minus plus. Okay, and the 15 will be the LCM. So 15 will be LCM. 3 5s are 15 and 5 2s are 10 plus 5 3s are 15, and it will be equals to 13 by 15, and when we solve the value for v, it will be equals to 15 by 13, and it will be equals to 1.13 1.1 meter. As we can see, the image distance is positive. Image distance is positive means the image is formed behind the mirror. Image is formed behind the mirror always be virtual. So the image formed by the convex mirror here is a virtual image. Here is the position, and the nature will be virtual. Virtual image is formed because v is positive. If the v is negative, then we say the image formed is real. But when the image formed, the value of image distance is positive, then the image formed is virtual. Okay, next we have to find the size of the image. size of the image. Okay, size of the image will be uh, size or magnification of the image. We have to find the magnification. Magnification will be equals to m will be equals to h2 by h1, and it will be equals to minus v by u. Okay, so we have the only data v and u. We don't have h1 here and h2 here, so we can also we can only find the magnification, and the magnification m will be equals to minus v by u. In place of v we will put the value 15 by 13, and in place of u we will put the value 5. Okay, 5 5 3 are 15, and it will be equals to value of u will be negative 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 positive, and it will be equals to 3 by 13. As it can be seen from the result, that the result is less than 1, so the image formed is smaller than the object. Okay, image formed is smaller than the object, and 3 by 13, and the result will be equals to 0.23. So 0.23, when the result is less than 1, then the image formed is smaller than the object, and when the image when the magnification is greater than 1, then the image formed is larger than the object. Let's take one more example. A 5 cm tall object is placed at a distance of 30 cm. A 5 cm tall object, it means the height of object is 5 cm, is placed at a distance of 15 cm. It means the object distance is minus 15 cm. Sorry, it is 30 cm. Is 30 cm from a convex mirror of focal length 15 cm, of focal length 15 cm, and we know that it is a convex mirror, and the focal length of convex mirror is positive, and we have to find the position, size, and the nature of the image formed. Again we have to find v, so 1 by v will be equals to 1 by f minus 1 by u. Okay, put the value of f. We have 15 here. We don't use the negative sign because the focal length of convex mirror is always positive. Minus 1 by u. In place of u we will put the minus 30. Okay, minus minus plus. Now take the LCM. 30 will be the LCM. 15 to the 30, and 30 ones are 30, and it will be equals to 3 by 30, and it will be equals to 1 by 10. So the image formed 1 by v will be equals to 1 by 10. So the image formed v will be equals to 10 centimeter, and here we can see the image distance is a positive quantity. So here the image formed is virtual. Okay, image formed is virtual. Here is asked in the question that the nature of the image, what will be the nature of the image. So the nature of the image is virtual, and it is formed at a distance of 10 centimeter behind the mirror, and we have to find the magnification also, and the magnification also, then m, size of the image will be equals to h2 by h1 is equals to minus v by u, or h2 will be equals to minus v by u times h1. Let's put the values one by one. h2 will be equals to minus v, in place of v we will put 10, in place of u we will put minus 30, and in place of h we will put 5. Okay, cancel this term, 5 6 and it will be equals to 10 by 6, and this one will be equals to 1.6 centimeter. 1.6 centimeter. Here we can see that the height of the object is 1.6 centimeter and the height of the object is 5 centimeter, it means that the image formed is smaller than the object. Okay, these are the some examples on the basis of reflection and on the basis of mirror formula and the linear magnification. Hope you guys enjoyed this video. Thank you. Have a nice day.